Actually, you know what? Let's just drop that video and just look at this for a minute. We're gonna talk about some stuff. Not too long, not too long. I do need a web page though. I need a YouTube, don't I? Actually, we're gonna go into this site right here. Wait, what the hell? Wait, it's what is this? ITCworld.com. We don't want that. We want ITCworld.org.
I don't think that's the website.
Yeah, I didn't think so. Shoot. But I hope that's not coming up on stream, is it? It shouldn't be. ITCworld.org. World ITC. That's what it's called. So we're going to go to this website. This is what started it all for me 30 years ago, believe it or not. Well, actually, I actually started out in the world of what I would actually, you know what I could do? I could take this music and I could tone it down a little. It's kind of loud in my ear, but I could tone it down there too, couldn't I? Or can I? Yeah, I think I can. Wait, that's two separate. I want to hear a little music, but actually, you know what? Well, that doesn't do anything. Damn it. I got a problem with this one adapter. Anyway, let's see if we can get the website up here. And that needs to come to the front, doesn't it? So we put that to the top. Make it a little smaller, kind of fit it in. Get a little stars in my little campfire down there. Alright, let me set up my stream monitor stuff here. So like I found out about what's called EVPs, electronic voice phenomena. I probably should have put that in the stream, but that's kind of where I started. And you get these tape recorders, and they basically started out going to graveyards with this group of people. There's some groups where I live, and quite ironically, you don't really get a lot of activity, EVP voices, at grave sites because they're all dead. That's a very ironic, weird statement, but it's kind of true. And then when you get these groups of people, these ghost hunter people, they go out there, visit the websites, and they're talking a mile a minute. Everybody's talking. And then when you go to play the tape back, you can't hear nothing because everybody's talking over the tape. It's just so stupid, you know, what these people do. And they got the ghost hunter thing on Netflix and whatever. It drives me just crazy because all of this stuff originally started back in the 50s in Germany and some of these other countries. They had this tube type equipment. This person heard this voices over his TV, and he was wondering where it was coming from. It was probably coming from like another radio station or something. But I guess he was talking to it, and then from that developed what's called the Spiricom thing, which involves taking a bunch of tones, mixing them together, sending them out on a radio frequency, and then having these entities modulate these tones so that you can hear them. And so I'm asking myself, well, why 30 megahertz? Why 20? Why the CB band? That's the worst place you could put anything because there's so much garbage on there. And the noise actually is quite high in that frequency. The noise around 7 megahertz, I happen to know this because I'm an amateur radio operator, licensed advanced class. I know a little bit about electronics. Been studying it for over 40 years. I've worked in many different parts of industry. I've worked with the military. I've done all kinds of shit. So I pretty much know what I'm talking about. The lower frequencies have noise, but if you actually, we could look at a spectrum. Why don't I go ahead and let's see, radio, and the other, well, yeah, radio spectrum image. We want, what do we want here? This looks like a good one here. Let's see what this page is. And I want to go over to my website if I can get there and pause this. And I need to fix this. So we've got this picture. I'm just going to go over this briefly because it's important to get an idea of the overall picture of what I'm doing, which is alien technology. Now, all of this stuff that you see in front of you, this is man-made technology. A lot of it's pretty sophisticated. You know, where do we get this information? How do we build these things? You know, did we reverse engineer some alien technology like 50 some odd years ago? And that's why, like right now, our level of knowledge in electronics and data processing and computers is climbing logarithmically. We're not in a linear growth of science and technology. Our growth is non-linear. It's going up. It hasn't plateaued. It just keeps going up and up and up, while getting smarter and stupider at the same time. So we have, so that's a frequency in hertz. 1 kilohertz is 10 to the third. I think. 100 kilohertz, 1 megahertz, 10 megahertz. So radio is between 1.8 megahertz and 30 megahertz. That's your HF scale. It's called HF, high frequency. Then you have your VHF, which is 50 megahertz up to like 800, something like that, 800 megahertz. Then you've got 800 megahertz up to 1,000, 1 gigahertz. That's the UHF frequencies, or actually UHF starts around 400 megahertz and goes up to 1 gigahertz. Then you've got SHF, which is super high frequency. That's in the gigahertz range, like 1 to 20 gigahertz or whatever. Then you've got infrared. Then you've got your light waves. I don't know if you can see that little thing. Probably not. Yeah, you can actually. You've got light waves. Now, I don't know exactly what frequency that is, but it doesn't matter. It's very high frequencies, super duper. And then you got ultraviolet, so on. So when they built this Spiricom device, they inferred to use, I thought they were using like a audio signal and mixing that with radio frequency signals and coming up with this energy that these entities can manipulate, and then you can hear them on the speaker from the Spiricom thing. Well, the setup that I just read was they take the tones, they put it into a transmitter, and they transmit it on some frequency, and then you listen to that frequency on another radio or receiver, and so on and so forth. So, my problem with that is they're picking off a frequency, and my other problem I'm having is I think I want to get rid of that music. It's driving me up a wall. My problem, well, I don't, it's not really a problem, but frequencies, energy, I don't want to go into all the formulas and stuff like that. That would be interesting to do at some point once we get some circuits going. Um, so how do other dimensional beings receive this energy? Do they see it like a glowing light or whatever? And so, and even then, where would they be in space and time in order to locate such minuscule amounts of energy? Theoretically, the whole universe is connected. We're connected through quantum states and spinning electrons and photons and protons and stuff like that. Where is the dividing line? Where's the um, not the border? Am I thinking border? Um, like it's like a door, I guess. So you've got one room, and then when you open a door, you're connected to another room, and the other room could be a mirror universe, could be like an alternate universe, whatever. And so, but it's made up of a different property, and what they've discovered over the years is what's called chaos and complexity theory. And in this theory, I'm going to go over this again real quick too. We have here what's called the Mandelbrot set. And in the Mandelbrot set, actually, wait just a second. Let me go to YouTube. Let's see here. Can I? Wait, Mandelbrot set. You Zoom. Let's search that, and then videos. Mandelbrot Zoom sequence. So here we have. Let me pause this. Why is this so big? Jesus. Where's my thing here? Okay, so here you can see, if we start from the beginning, there's a formula. It's a fairly simple formula. It involves real and imaginary numbers. Now, imaginary numbers, how can an imaginary number be real? Well, it's a real thing. Just trust me. And I'm not going into the math about it. There's a sequence of numbers, and these sequence of numbers repeat itself. And if they are within a constrained limit, those numbers can either cycle each other, or they can go into a space that's called a fractal dimension. Now, fractals, this is a fractal. And so what happens is you have these designs, these mathematical designs. You're looking at like here, you're looking at a two-dimensional picture. However, now, two-dimensional or not, if you notice along the sides of this Mandelbrot set, you will see a picture that looks like the original picture. And that's because fractal design involves self-similarity. There's sort of a problem with that, because if it keeps repeating itself, you're always going to come back to the same position, like a circle. You start from the circle, you go all the way around, you're back at the beginning again. Alpha and Omega, God, sort of. But So let's play this video and watch what happens here. So it just goes closer and closer and closer. And I don't know how they managed to do this video, but it's quite interesting. So now let me stop it here for a minute. So now you've got the self-similarity, the black holes there with the little things sticking out, and you've got some other stuff going on here on the outside. So that looks quite a bit different from the black portion. And if you look on the large black portion, you see repetitiveness. So now you ask the question, now you've got this space here. You've got this purple space, and you've got that space. That's all infinite crap that's not constrained. Okay, but then you go zoom in and watch this. Just watch this video for a minute. Okay, wait just a minute. Hold it for it. Let me go back. Let me just go back a bit here. Look at the spiral design. If you sort of remembered, we talked about phi and how it exists in nature. This is an example of phi right here, the spiral. That is based on phi. So how is phi involved in a number sequence that has nothing to do with phi? And yet there it is. It's right here. But that number sequence did not evolve, or that number sequence evolved from a set of numbers that had nothing to do with phi, because that's these other areas. But anyway, we'll just watch it. So now there's going to be another question that's going to pop up. So like if you look here, you really can't see that black picture, right? And then the question is, what's inside the orange space, the yellow space? What is in there? That's sort of a question, but that's not where we're looking. Let's keep going. So now you've got to ask yourself, there's the repeated set again. There's the phi on four sides. There's a lot of similarity. This expands out to create another one, and another one, and another one, and it goes on and on and on into infinity. Now here's the key point. This whole setup where this goes on to infinity, where's the beginning and where's the end? And how is it that this centerpiece gets replicated so perfectly when you get closer and closer and closer? There's the same design all over again, but now look at this picture. Look at what's on the outside that wasn't there before. This is all new creation, the deeper you go into the system. Now there's some more entanglement. This would be called quantum entanglement, how these things get connected. I mean, this is a massive computer designed this. Now we're going into the color. It seems like one color area. Look how it spirals out. Phi is involved in this, the golden ratio. It's crazy. Now we've got a different design of the original. This is another Mandelbrot set. This dark area, this is a type of Mandelbrot set with different coefficients. So the question is, does that Mandelbrot set create the original one, or does the original one create that large Mandelbrot set? Here's another one. You could draw this picture and create the set with it. Its outward spirals are slightly different. There's phi in all its beauty. And it just goes on and on and on. So if we were to go back, let's see if I can find a good example. Maybe this one. Right about here. So the question is, and what we try to do in fractal and chaos theory is we try to determine exactly where the border is. And common theory says that you can't cross the border. And yet here's proof, undeniable proof that the border was not only crossed, but the border was fed information from this beginning. Because if we go back to the beginning and we look at this picture, we can see all this fuzziness, these little streamers that are pointing out. And way over on the left is another recreation of this large Mandelbrot set. It's the same thing. So the border is fuzzy. I guess we could infer that the border is kind of fuzzy because there's a lot of information in there. But if you look at the Mandelbrot itself, the black circle, which was the beginning, there's a very sharp defined line. But in fact, you could get closer and closer to that defined line, and you could still, like if you look at the top here, it's still kind of it's just like there's a space, there is a dark space in there. So maybe that's an extreme amount of energy. And lower amounts of energy kind of filter out. It starts low and then the energy gets larger as it goes around the circle. This is created by a real and imaginary set of numbers that repeat itself into such a sequence that it doesn't go into infinity. It creates a stable state. This is what the Mandelbrot set is. It's a stable state of infinite pictures. So how does one determine that? That's because that's the science of this whole thing. What does that have to do with what I'm talking about? It has to do with being able to cross the border, to send information across the border. What is the border? The border is infinity. You can never reach the border, but yet here is visible proof that the border was breached. The border was breached. It was never reached, but it was crossed over. That's what the term a wormhole, you create a system and then you go immediately from one area to the next. So you are traveling faster than the speed of light. You are traveling a distance that could be gazillions and gazillions of miles, depending on where that image that you created exists in the other time stream, in the other dimension, in the other whatever. So we can create dimensions. We can create dimensions, and what they are is they're called fractional dimensions. Thus, the term fractal. So when we design something, my theory is that we want to create a stable, infinite area of study. We can do that with electronics, we can do it with physics, we can do it with almost anything you can think of. But when we're sending tones out on a frequency of 30 megahertz, what's it doing? It's riding an RF wave. Now they're saying that works. They're saying that tonal energy, it's modulating an AM signal in an RF on an RF wave. So going back to the radio frequency spectrum, we're sitting at 30 megahertz. We've got an audio wave mixing with an RF wave and amplitude modulation. Now, there are other forms of modulation. There's frequency modulation, pulse width modulation, there's Morse code. There's different kinds of ways to transmit information. We need to know all of these methods, and we need to figure out what's the easiest method for these entities in other dimensions to use to communicate with us. Voice it's not so easy because it requires a lot of energy. When we do Morse code in ham radio, the energy that's used is 100 to 1,000 times less energy to transmit information. It's a dot and a dash. And those dots and dashes come together to perform letters. And the letters make words. So you're using binary information to create a data set. And then we have to convert the data set. Now, I've looked into there's other forms of binary communication. There's ASCII codes, there's radio teletype codes. Um, Now, the chances of the entities being able to communicate and understand other codes might be a little bit different. If we use tones, why can't we just use one signal, a Morse code, and transmit and listen for a Morse code signal back on the same frequency? Well, we're just going to find somebody else, some other person on the other side of the world hears that, and they're going to respond to our signal. So we've got to, and then the other problem with this is, how do we know we're not creating the messages and the interference ourselves? How do we know we're not talking to ourselves? How do we know that some part of us exists somewhere else, and then we ourselves are creating the very messages that we want to receive? We need to eliminate that possibility, and there's a way to do that. How we do that is we use a different language that we don't understand. So it is physically impossible for me to talk to myself in a code that I know nothing about. So if I send a signal out on an ASCII code in some form of medium, there's no physical possibility that I could get a message back with that ASCII code by sending it with my own thoughts. There's no way. Morse code, maybe, but ASCII code teletype, it's still a problem. So if we do it in a different language, if we send a code in French, let's say, it would be more difficult for me to produce a viable return message in another language. That eliminates the possibility of me talking to myself, of me creating the very research that I'm trying to discover. So that sort of solves that problem, and we can figure that out later. The other thing is, let's operate on frequencies that it is impossible for anything else to communicate with in a very small confined space. So if I use a magnetic field, it would be virtually impossible for someone to send out a CB signal on a radio and have it come out on a magnetic field. Now, I've got a ham radio right next to me. I'm a licensed amateur radio operator, and I can send out signals of a certain amplitude, and I can monitor those signals off of the magnetic field to see if there's any interference. And that's basically what we're doing, is we're taking all the frequencies from 0 up to the frequency that we're studying and making sure that there's nothing interfering with that information that's coming from that magnetic field or electric field or static field, that kind of thing. There's also infrared and ultraviolet, two other waves that exist in nature, and there is no way that information is going to come across those frequencies and the light waves. So that's the general way that I'm looking towards to be able to send information. But in the process, that's the final output type of thing. In the process of doing that, we need to create certain, how do I say it? Well, we have to make transducers to change energy from one energy form to another energy form that we can pick off information from. So if we get a light wave, we might use an optical coupler with the light wave. And as a matter of fact, there's an optical coupler let me opto. I think it's called opto, and I think I have some of these. Free space optical isolator. I don't know exactly what that is, but it's very expensive. Let's look up image. Oh, wait just a minute. Hold on. What did I just see? Let me go to another YouTube thing. Frequency, and let me just verify that we're doing what we're doing here. So another thing that's important is to know the frequency response of optocouplers. What is this here? Because we want to know that can optocouplers handle voice frequencies. So frequency response to the optical coupler, frequency response to the optical device under a pulsating frequency of 5 kilohertz. Output signal. Input signal is down at the bottom, and there's an output signal. That's only 5 kilohertz, so that's not very good. This is ResearchGate. I don't know what the fuck that's all about. So I guess we could. The thing about optocoupler is interesting. They're talking. Okay, here's one. Minimum typical max frequency of 1 megahertz floating capacitance. Wait. DC 500 volt. That's isolation resistance, transfer ratios, terminal capacitance. Doesn't rise time with a load of 100 ohms. Well, we wouldn't put 100 ohms on there. Propagation delay is more than the SPI clock period, 1 over the frequency. In this link, you'll understand how to choose a suitable optocoupler for your bus. Yeah, of course not, because it's stupid. So basically, we could just run a signal into an optocoupler. I got a bunch of these. They're very inexpensive. So actually, it looks like we have an LED, and then we've got a device that picks off the LED and sends a signal out. It's separated, isolates. So you could use that transistor side as a power source to turn on a light, for example. It acts as a switch. And there's frequency responses with this. That light beam is an enclosed area. And it doesn't matter if we're working on something that's in another dimension. It really wouldn't matter if the area is closed or open. What makes it that working in a certain area that this it's even better because it's isolated. But it's only one frequency light form. It's a very narrow band of frequency light form. If we were to say, if we wanted to Well, you could use the output as a means, like you could transmit the tones, let's say, into the optocoupler. You're sending a signal on a light wave. Turn the tones off and then listen to the output of the optocoupler. Or actually, what you're doing is you're putting the tones in. First, you're transmitting your own voice across the tones. Then you are shutting your voice off completely and then listening to the tones to see if there's a response. So this is possible. Now, I talked with a fellow by the name of Erlen Babcock. He was a test equipment specialist with some big companies, and he worked with them for many years, and he also studied what's called ITC. ITC is what I'm doing. It's called Instrumental Transcommunication. Using alien technology to communicate with aliens. No, that's my goal. However, it could be we don't know who we're communicating with. If we get a signal from anything, a being, a person from another dimension, that is enough to know that we've communicated. We've created a portal. We've created a wormhole to access a dimension in a certain point in time, and some being on the other side has, and there's millions and millions of people and beings that exist all over the universe. And you could say to yourself, well, I'm bridging a gap. So how does this bridge a gap? Okay, there's no, we haven't created this we haven't created this stable fractal situation. So the question is, if we had a feedback loop between these two devices, and then we could create the wormhole in that space. But it would have to be, how would you do that? The only thing I can think of is you'd have to have an open circuit to be able to control, because you can't physically connect that. We'd have a feedback circuit. And here's the problem with this. You have to create a feedback circuit that's stable. So there's a term called resonance. If we create an environment that produces a certain frequency artificially, then that's called resonance. But the problem with that is that resonance has a bandwidth, and the bandwidth is usually narrow. So maybe that's helpful. Maybe we can create a resonance with a wide enough bandwidth to allow audio communication and in this feedback loop. How would we do that? That's interesting. I wonder if I've got an optocoupler. If I don't. So the other thing you can do, so this is an idea. This is one idea. We have to know the frequency response. You just send frequencies into this, and you monitor them on the output, and so on and so forth. There's a circuit right here.
Hi guys, in this lesson I will explain the basic structure.
Okay, well, let's go ahead and listen to this, because this might be something we can get into. Let's go ahead and look at YouTube, which, what is this? shit. Video camera, that's my stuff, right? Yeah. This website. Alright, I'm just gonna do this manually here. We'll just bring this over. We'll watch this video right here.
And working principle of the optocoupler. Optocoupler is a circuit element that can control high currents with low currents without an electrical connection between two circuits, and it provides electrical isolation to these two circuits. Thanks to optocouplers, different currents are isolated from each other and flow safely in the same circuit. As you can see in the figure, 4 and 6-pin optocouplers are widely used in different models. So, let's see how is the structure of optocoupler. For example, the 4N25 optocoupler.
So you can make your own. And I have these. And I was told by Erland, which I mentioned his name earlier, he's passed away, by the way. And me and my wife, who has also passed away 5 or 6 years ago, it's just 23, 6, well, it's been 7 years now, I don't know. There's another device, it's called a photocell. Now, he told me that the photocells don't work because their frequency response is too slow. And I pretty much agree with him. He knows all about frequency response. The best frequency response item is this phototransistor. And he tried to do some work with lasers and had it hooked up to speaker and stuff like that. He claims he got something. I have his original tape, and you cannot define anything from it because I don't know what he did, but it doesn't work. It didn't work. He was on the right idea. He just passed away before he could finish his experiments. Supposedly his son took all his equipment. I actually have a bunch of his equipment, but I didn't get all the good stuff. And it doesn't really matter either because I have what I need. So the phototransistors have a much higher frequency response. They're quicker and they can pick up the audio better. So we could create our own optocoupler if we wanted to, and I got all that stuff. And also, he's got an infrared LED, and I have LEDs of different frequencies. You know, we could fire them all up. We could fire up all these LEDs with different frequencies, send information into them, and then try to figure out which one is giving the best signal. I mean, there's all kinds of ideas here.
Of an infrared LED and a phototransistor. Infrared LED emitting infrared light and phototransistor, which is triggered by this infrared light, are combined into one, and optocoupler is formed. An infrared LED is a diode that emits infrared light. The phototransistor is a circuit element triggered by this infrared light. These two are combined to create an optocoupler. Let's simulate a circuit that I drew in Proteus to understand the working principle. I have drawn two circuits here. As you can see, there is no electrical connection between the circuit on the left and the circuit on the right. The optocoupler provides isolation. Thanks to the optocoupler, we can wirelessly control the circuit on the right without any electrical connection with the circuit you see on the left. This isolation is provided by only the button in the circuit on the left. A low current will flow through with Arduino because Arduino gets damaged. What we can use is the motor control circuit as you see here. In this circuit, we see that a motor can be controlled with the Arduino microcontroller circuit. The isolation between Arduino and the motor is provided by the optocoupler. It's impossible to directly control a motor that draws a high current with Arduino because Arduino gets damaged. but we can provide isolation with an optocoupler without an electrical connection between these.
Yada, yada, yada. So what we're doing is, I've got Arduino for other stuff, crap. But what we're doing is we are putting audio signals through the diode, through the infrared LED, through the whatever the LEDs. We could put tones through there. We could combine AC on the DC, and then we could use the photo transistor to pick up the tones. We could actually build a circuit like that. But then you only have, it's still riding on one frequency, the frequency of that LED. So now the question is, you've got to create a field. We have to create a field that's an infinite field of light. And the way to do that would be to send the light source into a mirror, have the light source bounce back from that mirror to another mirror, and have the light source bounce back and forth continuously like a laser. Now you're creating a feedback loop with light, and you've got these tones riding on it. So then you would probably do that in a semi-enclosed area, so that you could focus the light using a lens. You could try to get it so that the tone frequencies or the light wave is resonating, and you'd have to be careful because then you're going to be developing a lot of heat. You'd have to have a way to dissipate the heat. There's that, you run that through a device that splits the waves in half. Then now you've got a signal that has noise on it. It's got light noise, and you have to run that signal into the two circuits using the transducer as the input. You would run those two signals through the circuit that we're going to build in this lesson. So there's that whole idea. And back to the radio frequencies, you got all that different frequencies and stuff. And so the idea of, so what we could do here is just show you really quick fractal dimension images, Sierpinski gasket, so on and so forth. The log of the number of self-similar pieces to the log of magnification. Well, that's kind of infinite. Here are fractional dimensions. These are different areas in this design. Let's see, what else have we got here? A lot of people don't know about this. This is not a normal. Why would anybody be interested in a dimension between 1 and 2? Because it defines a border. It defines a border that we can cross, because we know that there's a number between 1 and 2, and we know how to get to 2. The question is, how do we get to 2? So here's the self-similarity again here. What is this picture? This is accomplished by an algorithm called box counting. It goes through some theory, and it shows you some numbers, so on and so forth. So in fractals, if a dimension goes off into infinity, there are certain states. There's There's a cycle state, there's a zero state, there's a one state, there's an unstable state, there's a stable state. And you can determine these states of existence with differential equations. And we don't typically need to go into the math for that. Um, so this looks like a fairly linear graph of an increase in dimensions. And it talks about a slope here, the rise over the run. Note that the theoretical fractal dimension for a snowflake curve is the log of 4 divided by the log of 3, which is 1.262. So for any number of squares, it's following a linear path. That linear path goes off to infinity. Now here on the right, we've got a program that does not go into infinity, and a dimension was calculated, and the dimension itself gets closer and closer to a certain number the more iterations this goes through. And we were like phi is a number. So if we could take the reverse of the fractal dimension as phi, then we could create an island and see what it looks like. You know. But it looks like a lot of these dimensions are between 1 and 2. So, and this is a two-dimensional object created by a one-dimensional calculation, I think. So it's a two-dimensional representation of a one-dimensional number, you know, it's crazy. Yeah, so on and so forth. Now we're talking about Brownian noise, which is an infinite thing here. They're sort of picking off a certain dimension for that. Etc., etc., etc. Calculate the mean and variance of the number of black pixels in each box size. I don't know exactly why they're doing that. Multifractal spectrum. Recurrence plots. Now here you can see a very sophisticated looking moire pattern. Which is kind of interesting looking. Approximating self-similarity. Anyway, we're in three-dimensional space, but we're getting a little bit beyond what I wanted to talk about. So this site here, I told you before I got involved with EVPs, which is electronic voice phenomenon. On this website here, talks about that subject. Can't really see that very well. So on this website, this is worlditc.org. There are things in here that I don't, I take with a grain of salt. Here's a picture of George Meek with his Spiricom device. In this picture, you can see on the top section, he's got 1, 2, 3, 4, 5, 6, 7 tones, and he can adjust each one of them. And he's got that going into a radio transmitter, and then he's picking that off with a receiver with big ass pieces of equipment. I got little ass pieces of equipment. So if we go, it talks about an introduction, bridge between the terrestrial and the beyond. Here's George Meeks in contact with Konstantin Raudiv. Raudiv is like a diode circuit. There's pictures. They did Erland, which I talked about earlier, took video signals and fed the video signals back onto the TV so we could produce a feedback loop. And in doing so, I tried to do it, and I burnt up 3 VCRs, so I won't be doing that again. But you can do it also with digital equipment, and I don't think it works as good because you don't get the dispersion effect, and that's where that border is between one side of infinity and the other. That's that fractional dimension. He chatted with invisible friends by phone. Watch your ears, this might be loud.
The system on my side. Do these things sound like a good idea? Sure, very good.
I don't know what that was. So there's something in there. So the audio signals are very low. They need to be amplified, run through a filter. We could actually do that with computer now. We can run signals back into the computer. If we're not using a computer to produce tones, I suppose we could. Now, a lot of this stuff like the spirit faces, people could be shaking the camera and taking a picture of it. It's, I don't deal that much with pictures because of that very reason. What is ITC? Instrumental Transcommunication. Tape recorders, you use a tape recorder. I use the mini cassettes tape recorder. You talk on that and you wait for a response. Those worked the best for me when I was doing my EVPs. Because of no interference type of thing. And I had some really scary experiences with it, and I stopped doing it for not only months but for years, a long time. And it works. Something happens. I got a female voice that talked back to me, and she said the same exact words that I said, and it was in a female voice. Go figure, okay? That's when I stopped. So we should use resonance, human resonance points. Resonance is something that's compelled by stimulus to vibrate. We want to have resonance because it adds to the signal. It adds more energy, a lot more energy. Um, so there's that. Now we've got, it talks about what is energy, talks about what is resonance, etc., ITC history and future. Uh, all right, well, I've got my whatchamacallit thing on. So it started here back in 1901. An Catholic altar boy said he was communicating with a small box. The priest would speak into a box and it would speak back. Now that's kind of interesting. So you could create a resonant chamber, and but there's no energy going on inside the resonant chamber box unless if you were to add the tones to a box. In the 20s, Thomas Edison. In the 50s, it talks about two different, this person was a music lover. I was born in 58. Frederick Jurgensen. Then we've got Dr. Konstantin Rodiv. Did some stuff with diodes and stuff like that. Then we've got 1971. Now we've got George Meek and Hans Heckman. Opened a lab, etc. This is back in 71. Now I will tell you that near where I live, I know for a fact that they were doing some experiments. They were doing top secret experiments with low voltage energy, and something was discovered up here, and I don't know. The owner of the place where I used to work was involved with that. So now we got Sarah Estep. Yeah, I think she may have passed away. There were ghost hunters, Ken Webster's. This is back in the 80s, 19. Then we talk about Mark Macy. And some stuff happening there. This is going on in Germany and places. There was a seance thing that happened. I forget. I don't know if that's in here. Now we've got, where is the research? Where's the research? Okay, right here. You've got to be careful of this menu because you can lose yourself. So there's sample contacts, research results, theories, tips for experimenters, etc., etc. There's also some websites that are not working anymore that I used to belong to. There's all kinds of stuff on there. Work groups. So I don't think it talks about, it just tells you to get into groups to do things. Decency for skeptics and results, for skeptics and realists, more ITC information, more about World ITC, events, donations, guest book, researchers' results, and theories. So if we look down this list, you will find, what the fuck? They took off Erland Babcock's research. Seriously? Wait, these are theories. Victor Zamet, I don't really know about his stuff. I am skeptical of Mr. Zamet. Periodical CV. Why is Erland Babcock's stuff buried? Earnhardt. Researchers' results. Erland Babcock right here. And Annabella Cardoso. She does things with pictures, and I think she's still alive. Sarah Estep is the EVP person. She's passed away, I think. Mark Macy supposedly took all that information, and then George Meek was studying scalar technology. Voice characteristics, transcript of the recording, Spiricom, the Spiricom report. This talks about tens of thousands of hours spent over 25 years. Hundreds of EVP researchers in Europe have clearly shown that some form of supplemental energy must be utilized to prevent even individual words or short phrases to reach the level of audibility. 11 years of efforts by metascience researchers established that the energies involved in the different levels of the world of spirit are not part of the electromagnetic spectrum as presently known. But we're using audio tones. Have any chance of detecting such energy is necessary to create some means of coupling the spirit energies to the devices at our disposal. Transceivers, speakers, microphones, tape recorders, oscilloscope, hence it seems that some form of transformer, coupler, or transducer must be utilized as an interface between the energies of the dead. Well, they're not dead. If they're dead, how could we speak to them? And the energies used in our electronic devices, etc., etc., etc. And then it actually talks here to a known voice. That system, which we call the Mark IV, uses the energy input from 13 different audio tones, which seems to be more effective and constant energy source than the merciless energy used by EVP researchers, etc. It also seems to use the auric energy field of one of our technicians, who is such an advanced psychic that his clairaudient and clairvoyant abilities have on occasion allowed him to converse with us. Blah, 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 blah. We caution that merely building equipment according to the diagram of the Mark IV may result in a waste of effort and money unless there is some form of highly charged human energy field available in combination with a mixture of 13 audio tones. Well, that wasn't discussed. Okay, that I totally disagree with. Okay, and here's the problem with this. If you have someone that's so intent on trying to communicate with something in some other dimension, how do you know that you're not creating that information? Okay, I disagree with that. I disagree. I have to disagree. You have to be totally neutral. You have to be independent of the research that you are trying to create, trying to research. You cannot be connected physically, mentally, spiritually, or anything with this research, because if you do, there's chances that you are going to create the very research that you're trying to research. This is a problem, so we try to stay neutral. So I disagree with that. I believe that the energy itself is enough to communicate, and the feedback field is enough to create a resonant source of energy. Maybe it could be at human frequencies, like the delta frequencies, 8 hertz, 5 hertz, or something like that, bouncing back and forth, a slow. But light travels at the speed of light. It travels very fast. So if we were to slow light down, you could put light through a medium that slows the light down. You could put it through, let's say, water. Or what's that going to do? Is it going to slow it down? Or is it just going to dissipate the energy? Light is light. It's going to travel at the same speed regardless. But if it's slowed down in some fashion, maybe there's something to that. Electrically activated quartz crystal utilizing ultraviolet light, living plants, and plasma of an open flame. Yeah, I did the open flame thing with 90-degree phase changes in the amplifiers, and I did get some signals. However, I discovered that the output of those signals was pulse width modulated. So I need to build, this is a desperate thing, I've got to build a pulse width modulator audio transducer. This needs to be built because this energy is transmitted not by amplitude. It's transmitted at a constant amplitude, much like frequency modulation, and frequency thing. And I got a frequency modulator now, oscillator. But we need a pulse width modulated system. That has to be built. So there's some stuff here. I don't know if that's George Mueller. I don't know if the design of the Mark IV, there's illustrations. The Mark III and the Mark IV, is this? Oh, there's a circuit here. Oh, damn. Oh, shit, look at this. Time crystal generator. Red, violet, blue, green, yellow, orange, red, infrared. Now, how did they relate those semitones, the octave, to color? That's just one octave. There's the notes. Beats per second in equal tempered intervals from C to C inclusive, correct to, yeah. Conclusions. There's a signal generator, an RF signal generator and receiver. Oh my god, they're so big. Metascience multi-tone generator. It's a little bit overkill, isn't it? So here you have all of these tones going into an audio amp, and so on and so forth. I did pick up a bunch of resistors. I picked up a bunch of variable resistors. What am I thinking? My brain needs a break. I wouldn't combine them all like that. You'd have to have digital separators in there. I ran into a problem with that last night, trying to do that circuit. All I got was so I would have to use, instead of a digital circuit, I'd have to use a transistor buffer. That's the thing. So did I put in discrete circuits on my... I did. So we should talk about that for a minute, okay? So if you have integrated circuits, which is chips like op amps that I was working with, there is a 10 to 100 times worse situation where the energy is going to get into the op amps because of so much shit going on in there. If you have a transistor circuit that does essentially the same thing, you only have some external resistors which can pick up noise, but the transistor is going to be less susceptible to extraneous noise. And you could use a very small gain, like a gain of 10 or something. Let me think. That would be for a buffer stage, a buffer between the output of the tone generator. But then you'd have to have 10 or 12 different oscillators. Let me see something here. Let me just crank this a little. Get rid of this, get rid of this, get rid of this. Transistor, tone generator. Simple tone generator circuit using transistors. Images. And we don't need to have it control a speaker. That's an FET. We don't want to use an FET. We want to use here's one here. It's using 2 transistors. The resistor and capacitor are the frequency of the tone generator. I don't know what that other thing is. That's an FET going into a 3904, which is driving a speaker. Oh, you've got a switch and a variable resistor. I don't know what that FET is. But you've got as a variable capacitor, single transistor sine wave generator. There's no variable resistor in there. I've got more transistors than I do anything else, and I might as well build something to put them to good use, right? Here's one here. There's a NPN and a PNP, and that's even driving an 8 ohm speaker, which is kind of crazy. This looks like the easiest one. Where's the capacitor? Right here. This looks pretty cool. And there's a variable resistor in there. Ooh. There's a Colpitts oscillator, which probably would give a better distortion. I don't know what that's using. That's all too complicated. Actually, let's see. Oh, shit. Three simple metronome circuits. Okay, that's the same one. Table of contents. I don't know what that BC549. That's actually 2 NPN transistors. BC549. BC549. Equivalent. Both are low noise general purpose type transistors. It can't be used to switch heavy loads. Yeah, I don't care about that. Can I use NPN? Can I use okay, here's what's the difference between oh Jesus, that's not the one I just had. Can I use these are not direct substitutes. BN49 is an NPN transistor. Figure out what the fuck here. Just about any small signal NPN transistor that can handle a few hundred milliamps of collector current will probably work. 2N4401. However, it's not sure how it's hooked up. It is a small signal NPN but has particularly wimpy max collector current of only 100 milliamps. If that's all you need, like driving a relay, then that's fine. If you need 200 then that's not fine. Collector current. This is 800 milliamps for a 2N222 and 100 milliamps for that. So it depends on what kind of current you're putting through it. So yeah, we could replace that. Why the hell not? Let's take a picture of this. As far as the output frequency, that's a PNP transistor, which is just amplifying that. And we are okay, let's take a picture of this. And we'll go to my project setup. And we will put down, what the hell? Huh. Let's just open this one. And put that in there. Crop, and we will save this. Save as JPG tone 1. Should have tons of them little freaking transistors. File, save as JPGs, and that's in my projects. Okay, good. Philosophy is 832. Go to each one. Change capacitors to it. The detail is other C in the circuit. Simple signal generator using A3906, which is a PNP. Generates signals both light and sound, alternating, which can be applied to work, for example, taillight of a bicycle, turn left. When entering into the power supply circuit, we have a circuit defined by 3906s. A stable multi-vibrator. That's a plus and minus. Buzzer. Alternates between light and sound. It uses begin flasher. What the fuck? Somebody doesn't know their fucking English here. The sound click. This video below here, tone of speaker. This person can't fucking, he doesn't know his fucking grammar. What the hell? That sounds horrible. What the fuck was that? Small metronome? Sounds like a damn fucking bee. He's got a fuse sitting on top of the speaker. Why the fuck did he put that on there for? Jesus, you gotta be fucking kidding me. I ain't building that if it sounds like that. Burglar alarm, power controller, learn melody tone generator. Jesus. Audio frequency generator circuit. We need something that has a good tone to it. I mean, there's like, actually, you know, come to think of it, we could do it with this computer. Let's do it with a computer. If we output, let's see, I could probably do it with the second computer. And I got the output from there. I could run a cable from there into something. I could figure that out. We're not going to worry about building the tone generator. We're going to use a computer. But what do we got here? We got audio tone into RF signal, RF radiation, low power, AM receiver into the speaker. Now the speaker produces sound waves. Now the microphone goes into the tape recorder, records tones, modulated tones, etc., etc., etc. So here's the problem. The problem with this is number one. So they're generating the sound waves from the tones into open air. Not, they're generating it through a speaker. And a microphone is connected to a tape recorder. Here's the problem. You don't know if I believe that the spirit itself, the entity, is recording the information directly onto the tape recorder. I believe that it's possible. There is so much going on here with this equipment that you can't make a determination that what you're doing is an accurate lab setup because you don't know where that energy is coming from. If the energy is created with intention, the intention itself could cause a manipulation of the energy fields, recreating your own, it's a problem. It's a problem. So you don't know if the tones, even though they're going through the speaker, when you run sound through a speaker, what are you doing? What is a speaker made of? It is made of a magnet and coils. The microphone also, when I did my EVP test, I could get nothing with the microphone because the microphone took the place of it added noise. It added noise to the tape signal. The tape signal is going across a magnetic head. Now, I've got some really good tape machines here, and my theory is to pick up the signals directly off the magnetic head because I think there's energy going on in the magnetic field, and that's why I'm thinking when they did these experiments, they didn't take the magnetic field into account. You could get a direct transduced signal from the tape recorder to the speaker, and I just don't think that's my theory. Because the question is, if this was true, then why couldn't I just listen to these signals when I'm listening to the tape recorder? It's because you can't hear them live. You have to play the tape recorder back in order to hear the sounds. So what's that mean? It means that you're listening to magnetic information that was reproduced onto the tape recorder. When you hook up a microphone, all of a sudden it's not magnetic. But the tape recorder itself has a magnetic transducer. So you don't know, and I've proven this because I've done this without the microphone. It has an internal microphone. So it does use the internal microphone. There's still a mic there. But it still doesn't mean that the information came through that microphone. I think it was a variation of the energy existing around the magnetic field, and I think that's what made the recording. The reason I say this is because you can pick up RF stations. If you play a tape recorder and put it on record and just sit it out in the open and you play it back, what are you going to get? You're going to get noise. You're going to get a radio station. You're going to get crap picked up on that tape recorder that you don't want. And that's the problem with using a tape recorder. So if you use a discrete device, build a very simple amplifier that amplifies a magnetic field, that's what you need to eliminate all these possibilities of radio signals coming in there and screwing with everything. And Frank Sumption, back in the day, he come up with this ghost box where the radio signal sweeps back and forth really quick and picks up all the radio stations. And they talk into this thing. That was a big seller. People bought into that bullshit. And I said to myself, what are you doing? Just because it's energy, you're picking up people's voices, and they're going to take this voice, and you're going to hear some random voice that says something, and it's got nothing to do with what you're talking about. It's too much energy, too much variable energy that entities cannot work with. You've got to have a consistent form of energy. These tones are very interestingly, in my opinion, the thing to use. Description and theory. Okay, here's a Mark 5. Okay, now they're using electromagnetic microwave energy in a more controlled manner. 2 gunplexes as a source of microwave energy. We can get them from microwaves. Normal frequency of 10 gigahertz, the receiving and a 10 gigahertz transmitter. A varactor diode, when biased to the DC, tunes cavity, plus or minus, etc. Antenna. So now you're picking up a crap load of noise. This gain of 17 dB, blah 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 blah. The interaction between our systems produce 2 beat frequencies in the Schottky diode. Sum and the difference. The difference for the frequency 30 megahertz is also the intermediate IF, which is reduced in order to pick off the audio. It's just a basic. This is just a receiver and a transmitter at microwave frequency. Output feeds a limited discriminator, so we're talking about an FM signal, demodulated for frequency modulation. And they use a test tone of 1 kilohertz to align the antennas. And they also seem to have the 10-volt supply feeding both horns. Not very bright. Oh my God, they've got that right out in the open air. Look at that scope down there. That looks like the same oscilloscope I got here. Oh my God, it is. Are you shitting me? I got the same oscilloscope, but it's not working. I got it sitting right here. It's a very good scope because it measures very low voltage, and it's sitting. I have the very same oscilloscope which is that device in the middle, right there. I got that sitting right on my bench, but it's not working anymore. Something's happened to it. A tube might have blown or something, and I got stuff on top of it, and I just don't want to fix it. I really like that scope too. That's just crazy, huh? Isn't that cute? I got this was when was this built? 1977. 87, 97, 07, 17. Oh my god, that oscilloscope's over 40 years old. Isn't that crazy? That is just crazy. I think mine's better though. I think I got actually it might not be. I think it's the same scope. Oh, you know what's different? Wait. Yeah, that's the same identical scope is what it is. I got that same oscilloscope. Isn't that cool? It's kind of creepy. Now we got other ones here. The guidelines for further research. What are these? So it all boils down to using a basic tape recorder to record the energy. Again, right back down to magnetics. That's why I'm very skeptical of all of this. All right, this is one of the things that I did. Samsung growth interest of using plasma to achieve 700 hertz to 100 kilohertz audio, such device being developed. My ass. Considering use of a flame and a device for communications with persons living in the world of spirit, we have not been thinking so much of the use of the flame as a loudspeaker. Rather, that we have speculated the possibility that the spirit energies might be impinging on the flame, and the reaction thereon detected and eventually fit into the scope, loudspeaker, etc. One configuration could be shown here. So they did use a flame. I didn't know that. I don't think I read this. Maybe I did. Before concluding this greatly abbreviated introduction of flames, we rather jokingly mention what might have been the first recorded reference to it as a transducer. We quote from the 3rd chapter of Exodus. What the hell? And the angel of the Lord appeared to Moses in a flame of fire out of the midst of a bush. And he looked, and behold, the bush burned, and the bush was not consumed. Moses said, I will now turn aside and see this great sight, why the bush is not burned up. And God called him out of the midst of the bush and said, Here I am. And whether the speaker was God, an angel, or some other renowned being, we can be sure that he was a personage of higher level of consciousness. So the fact that this was mentioned here is interesting because I did do a setup with this. Oh, they've got that going through a prism. No, I didn't do that. They have a prism and a lens setup, and all I did was use photoelectric pickups on 2 sides of the flame, supposedly to separate polarization of the light form. I wanted to get, and when I tried to do that, the circuit was so damn sensitive that it didn't work, and I picked up something on the op amp, and it wasn't even connected to the flame. I'm just going to take a picture of this. What the hell? So I don't forget it. I mean, it's an idea, but it's really not on the top of my... It's not on the top of my list. Right now, the top of my list is to go over the secondary amplifier sections in order to separate the phase. I want to create a phase change to try and eliminate noise. That's what we're trying to do here. Well, that's interesting. I didn't know they did this. They put a prism in here. Electronically activated quartz transducer using ultraviolet light. Why ultraviolet? Why not any light? Why ultraviolet light? I just bought a black light too because I can't find my other one. They are composed of light at different wavelengths. We have confirmed that most of the inhabitants of the spirit world exist at wavelengths outside those which can be detected by normal human eyesight. That's infrared and ultraviolet. And I know about that. But you can't see light anyway. You see a reflection of color. This Sloan fellow said that the etheric world begins in the area immediately above the narrow band of light waves visible to the human eye, which is a higher frequency. Above the visible waves as etheric in the area above. So we're talking long waves, microwave, shortwave, beyond the infrared, visible waves, the physical world, ultraviolet, the etheric world. And I just bought a black light. And I was going to use infrared as a means of communication or light wave. I wish I had that damn. I really need that black light bulb because I can focus that beam better than that stupid black light. Although a black light would light up a whole room. That's interesting. So that's another thing it didn't really click into my head. God says you will only get the information when you are ready to receive it. Beings that exist in higher forms of vibration than us, quote unquote higher vibrational state, it says that the physical world exists in an area of visible waves. That's technically not true because we have radio waves. Infrared light is still, I don't know what it is. Is it? No, ultraviolet waves are still part of the physical world. All of these light are part of the physical world. But the physical world itself, I mean, it's less, how do we know, really? Dr. Norbert says that thought waves are just beyond the border of the ultraviolet light frequencies. Just beyond the border of ultraviolet light. Because I'm relating thought waves as our body is a giant receiver to energy, so that would be a much higher frequency than light, which is another thing. Light travels at a certain speed. All forms of light, radio waves, travel at the speed of light. In the photo taken in the Metascience Lab, page 10, we have the four conditions mentioned above. Centering white light source, two opposed lights. The lights are projected and they are sequentially repeated. The negative from which the photo is copied is larger and it clearly shows a repetition in cycles. So if you took a light source and fed it back and forth and you could create That is, you could do that with light. Creating a version of Spiritcom that can tap to the higher levels of consciousness. The most crucial problem in the design of any such communication system provides some point in the apparatus where the energy from the spirit can impinge on some signal that we generate with our equipment. This is a tough problem. Trying to get the thoughts of a spirit person to impinge on our interface for a signal, even if we use megahertz, gigahertz, terahertz frequencies, is like trying to mix distilled water with axle grease. But, and here we come to the hypotheses that make us created here. If mind and thought are light, Friday, if Finley was right, 1920, he said the etheric world starts with the ultraviolet portion of the electromagnetic spectrum, and if the mind projects two parallel streams of light as shown in Mike's photo, one up build a transducer that allows these two streams of light to modulate a beam of ultraviolet light and give us an instrumental readout via a strip chart, loudspeakers, or printout. We offer these thoughts free to all our Spiritcom researchers, term EVPs, blah, 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 blah. So here they're talking about modulate. Now, this is another problem, okay? The information that I got from the flame experiment was pulse width modulated, not amplitude modulated. Amplitude is a change of level. My theory is you've got to have a constant level and vary the frequency, because when you have an audio signal, it travels through time. If the amplitude changes, like from low to loud, you're only changing the amplitude. You're changing the amplitude and a frequency, and it's both changing over a period of time. But if you change it to pulse width modulation or frequency modulation, the amplitude is the same. So they got the right idea, but they're not using the right form of modulation. And I feel like I know this for a fact. And I just put that information right out there in the stream. I'm telling it like it is. Now, this one's using plants. This was another idea that I thought that entities could use plants as a form of, talking to us. Now, this picture has got everything. It's got the plants. It's got Spiritcom Center. It's got the pyramid. It's got the diode. I think the diode setup is inside the pyramid. It's got laser beams. It's got focused light from the plants. It's got the tape recorder and a Faraday isolated area here. This is my dream thing right here. Pretty crazy, huh? What else? So we went through the results to date. What is its potential benefits? Final word to fellow researchers. Let's keep it in perspective. Considerations regarding the ether. Direct voice. Instances of direct voice in the Bible. Results to date. Well, this is very, very old. We're talking 60s, 70s, 80s. The website is not updated. Taken from the Golden Scripts. The hour is at hand for such knowledge to be given unto man. This was 1941. Behold, I have chosen for you for giving of such knowledge. I question of whether this information, like very few people would listen to my stream anyway, and Nobody takes it serious. Except me. Okay, now that's very interesting. We're going to touch on this called the Michelson-Morley experiment. Encyclopedia. Okay, so this is the one where they wanted to detect gravity. They got a laser set up with a reference beam, and although ultimately it proved incapable of distinguishing between differing theories of the aether dragging, its construction provided more important lessons for the design. An interferometer sent a yellow light from the, or a white light from the axis through a silver mirror. It was used to split into two beams. After leaving the splitter, the beams traveled out to the ends along its arms, which were reflected back. They then combined on the far side of the splitter eyepiece, including pattern of deconstruct interference, etc. On the relative time it takes the light to transmit, etc. The Earth is traveling through an ether medium. So there's supposed to be a fringe shift equal to 0.04 fringes. His conclusion, what the Fresnel's hypothesis of a stationary ether with partial ether dragging would have to be rejected. He confirmed Stokes' hypothesis. Longitude and okay, so here the light beam, this delves into faster than light technology. If light travels at the speed of light, the time it takes for that light beam to get from point A to point B, okay, there's two beams of light, it's going to be different. And you can see the cycles on the bottom. There's a phase difference. There's a phase difference. So if we use higher frequencies like light waves, and we move the transducer, we might be able to also eliminate the noise by moving the transducer. But that movement would have to be done by a micrometer because the light waves are so small. And we could use a micrometer on a geared station with a long longitudinal connector to the. You know what? Let's take a picture of this because this is interesting. I'm going to bring up this. I'm going to bring this up here. He overlooked the increase in path length in the rest frame of the ether. This was corrected by the derivation and transistor can also be. Okay, well, I'm just going. Let me. Wait just a minute here. What do we got here? Assuming equal length arms that are inclined to travel, therefore the Pythagorean theorem gives the actual beam distance as thus, and consequently the travel time as thus, which is the same for the backward journey, etc., etc. The path difference in one wavelength, because the beams are out of phase by the same number of wavelengths. To visualize this, consider taking the two beams along, etc., etc. Observer co-moving with the interferometer. Mirror reflection. Special relativity. Now they've got these mirrors, and they've got the light going through resonators. Why did they put it through? Michelson with cryogenic optical resonators of a form such as used by Mueller in 2003. Why would they? Why would they put resonators in there? I mean, I'm thinking about that. Evidence for the isotropy of mass and space. Feedback. Why would they? Putting that light in those resonators is not going to do anything. Let's go here. Oh, I got my. I guess I'm getting hungry. I don't know. Let's crop this. We're gonna call this. We're gonna call this file save as DL over DT laser 1. Now what I'm going to do is I'm going to open up Paint with my program. We'll drop this. We've got a program. We're going to use the Paint program. Jesus, that shouldn't be open. Where's Paint? Right here. Let's get rid of this so I don't have a happy accident there. Okay, so we've got this. We've got this idea, right? As a shift in phase. So my theory was if I take, let's see, let's do, wait, I can't paint anything. Let's say we draw, let's see if we draw a line. Shit, it's got to be inside this box. So, okay, so over here on the right, we're going to draw, actually I could draw it on the bottom. Let's see if we have, wait, can I, what if I did a box? Okay, and we got this. Let's see, let's do a fill. Let's fill this with black. Wait, that's not gonna work, is it? Let's fill it with gray. Alright, back to the pen. So we're gonna do another box. And we'll make that, let's make it brown. I got this on a box. And what we're gonna do is we're gonna put this here. We'll fill this in. Wait, let's fill. Back to here, back to, let's see, white, pen, and the object is going to be shit. Actually, I'll use this one. I'll leave that open. Okay, and then over here, maybe we could use dark red. And I believe that's not exactly. I have to start with this corner over here. That's not exactly, wait, actually. Go back to black, grab a black square. Like so. And then we're going to fill this with black. Oh. Wait, okay, that's okay. I think I did this backwards. Shit, do I use... if I use a square... No, do I just want to select and cut? So if I do this, edit, copy, edit, paste, we bring this over here. And then we go with the red color. Actually, I could do it the bright red. This. And how do I... It's a line. Wait, didn't I just use... Okay, that's not very good, but it gets the point across. Let's see, let's use, let's use white. So over here, if I use a worm gear, actually, what color is that? White. Let's make it black. So that's like a gear. I've screwed this up. I will make this brown. No, let's make it red. No, let's make it yellow. then this is like maybe here. So what this is a screw, a micrometer. Actually, I should probably put down a text here. And we'll type in yellow, I guess, 24. Let's make this 20. Micrometer. Micrometer screw. And we want to adjust this. What do we want to do here? We want to adjust this other mirror. So if I draw let's see. Let's use this color. This color. Size here. This is the mirror, and then we could do a line like this. I'll just say like this. Am I doing freehand? I'm not. Not a very good. Not a very good thing. Okay, so what this is a micrometer, of extremely sensitive micrometer adjustment of that second mirror. So if we have, so then we've got two light sources, don't we? Longitudinal and transverse waves expected to be differentially retarded when V is greater than 0. We got a single light source. I mean, I don't know if I'd build it. I wouldn't build it the same way. I would build this differently. I'd build it like he had it. So if there's a light wave, if there's two light waves, one light wave is going into a source, the other light wave is bouncing off a mirror. Let me think here. If that, oh, it has to go through. It has to go through. Do we want the light waves to cancel? Why would we want the light waves? The light waves represents. Oh, my belly's like hungry. Shit. So if I do, let's call the dark wave the incident light. Let me do a mirror. Now this is actually going to be a green, actually it's going to be a purple mirror here, and we're going to do a prism. I don't know. Yeah, maybe I can do this. Let's see. All right. So a light beam comes in from the left to the right. It's going to bounce off. It's supposed to bounce off at right angles. So if I go here, how does it bounce off at right angles? Yeah, it does. So if we do a light wave and we make a line, and we go from here to here, and then listen to my belly, will ya? So now we've got the original line here. That line is going to come out here. Now we're going to change this color. A portion of that line is going to come over here. So we got to make, let's see, we'll make this over here. And this is a mirror. Now we've got a red line going from here. Oh shit, where the fuck is it? Wait. I'm going to make this a little bit crooked so we can see. Okay, we do like the red line. Oh shit. Let's see. Okay, wait. No, I made a mistake here. Let's select this. No. I'll just grab this. Oh shit, what did I do? Fuck. Fuck. I put a fucking dimple in there. I just want to get rid of this dot. Now we've got, let's use an orange line because it's going to be reflected here, 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 and go back up to here. And now we've got another orange line here. Wait, something's wrong with this picture. Wait, does that go through? Wait, there's something wrong here. I think we've got to have another mirror. Because what happens is, so this goes through here. It goes through this mirror. Orange. listen to my belly, will ya? No, we'll just make it. We'll just keep it the same color. What the hell? Then it's going to come back down here. And then we take the red color. I'm going to save this file. Let's just save it. Okay, so now you've got this prism in the middle. The light doesn't go from when it bounces off that inside of that prism, it comes down to this blue one on the bottom. When it goes back up, it's not going to turn right. It's going to go back out of that section to this mirror over here. And then it's going to bounce off again and go over here. And so what we need to do is we need to adjust. So this is a certain distance, so let's take a green here and a line. So we'll do freehand. We'll call this, actually we'll call this here let's see, we'll call it DB, and then down here we'll draw a lighter green line. From some point to here. This is A. And we'll call that D A. And now we can take our blue line again. And this device right here, we'll just make another arrow like this. Not very good arrow, but hey. Let me see how that looks on the stream. So that's looking pretty good. So this is a extremely small adjustment on this. And so what we're looking for is a maximum and a minimum light output. So a minimum light output would be 180 degrees out of phase. So if we have a signal that's going into, if we have a light source that it's got signal and noise. The light source is riding on the same noise. But is this going to eliminate it's going to eliminate everything. Unless we can have another source of light that only has, how do we, how, how do I do that with light if I have, what do I do? Don't I just add that into the same? That would be two separate light beams. Where's the box? Let's use a purple box. Let's use a purple arrow. We've got one light source. That light source has to be the same light source, except for one of them has to have the energy of the tones put in, and the light source has to be the same distance apart. I'm getting hungry. I wasn't planning on doing this here. I don't know. I'm thinking in terms of light energy. This could apply to magnetics. It could. Then there's. So this is actually a feedback path. This light. So let's talk about that. We're creating a resonant setup. This is using one light beam, and it's splitting that light beam. Oh shit, wait a minute. It's actually going to split off. The first signal's actually, you know what? Oh my god, I think I just fucking figured this out. Oh, this is going to be purple. First. No, wait. First. Light. Reflection. First light reflection. And that's purple. if that's the first light reflection, what the hell was I thinking? You see in that diagram above, why that would require me to impress the sound tones onto that mirror. That would be vibrating that mirror, essentially vibrating the light beam, but is that going to be amplitude modulation? Amplitude, if it's the same, that's taking an electrical source and vibrating it off of a. I could use a transducer. Oh my God. I could use, you know, those piezoelectric transducers? My God, I got one just sitting right here. I found one that's sitting in a very protective place when I was doing my cleaning. And I was like, what the hell is that? It's got shitloads of dust on it. And it's very delicate. But you know what? This thing has something very interesting on it. We're gonna blow that fucking wire right off. Oh, you've got to see this. You've got to see this. What is this? I don't know what that is. So, wait, let me get my. I get an idea where's. I want to save this. Save. And then we're going to go to my stream. We're going to turn on my video capture here. Look what I got, okay? This is a piezo element. I think I have a few of these, actually. However, and this will vibrate up to very high frequencies. We can vibrate this on an audio range. Well, guess what it's got on the other side? It's not very clean. And it's not very reflective. But look at this. You think that'll reflect a laser beam? Well, guess what? I just happen to have one. Where did I put the laser? I got a guitar over here too, which I played music last night. Oh shit, you know I'm supposed to do something else because, oh damn it the hell, I can't do everything at once. I mean, if I'd gotten a message, it's 5, 6, 7, 8, 9, 10. Wait, did my messages even get read? No. Maybe she's sleeping. I just... What the hell did I do with it, though? Is it in here? Well, those are all magnets. Which really shouldn't... I didn't know those were sitting there. Those magnets shouldn't be by my electrical devices. God, I hope I'm not 3 sheets to the wind over there. I also got another little laser spotting scope, but that's not what I'm looking for. What the fuck is that laser? Shit. I don't know what the hell I freaking did with it. I got two lasers. I got one in a big box, which probably doesn't have any power. What's in here? I can never find shit when I want, you know? Because I got so much shit. I got adapters. I got a lot of stuff. You know, and I have to go through everything to look for shit all the time. But it's par for the course. That's what I do. It's a brown colored looking laser. And, by the way, as a side note, I've got all the front surface mirrors because I was planning on doing this for a long time. I don't know what's in this box. This is my big project, and I was thinking lights. Well, laser, okay, it's a light frequency that we can see, and they're talking about ultraviolet, and so what we're actually doing is we're calibrating the mirror source with a laser, and then we can enter in the other light frequencies into the system. Where the hell's that fucking laser at? I thought I put it in a box somewhere, and I don't remember where the hell I put it. There's some microphones. No, it's not in that box. What the fuck did I do with it? Maybe it's on my desk that I don't know of. Fuck on my nose. Got so much shit. Oh, webcam. There's the laser right there. So I got thin wires dangling from this pizza thing. So here's this, okay, and I've got a laser light. Oh shit, that's not the laser light. That's just a flashlight. Where the fuck did I do it? Was it in that little box? Big box? I also have two slightly high-powered premium lasers, which need to be worked on. Fuck. What did I do with the other box? Did I put it in there? Oh, I know where it is. You bear with me here for a moment while I get up off my lazy ass. I did do some work today, though, by the way. I did some work. I also have a very high-powered white light source with, I got lenses, I've got flat surface mirrors, front surface mirrors, and I'm losing my nuts. I got shapes for the laser setup, and they're falling out of the box. There's a capacitor. What the fuck is that doing there? Alright, does this work? Because I don't remember. Alright, this one works. All my laser stuff needs new batteries, and that's a separate topic for discussion. Alright, so I even have a lens here. We have a lens, and if we And even some of the light is reflecting off of the lens. So if we put the lens here, you can see that some of that light is reflecting off of the lens. So there's a reflection there even coming off of a lens. So I could even use a lens for that matter. But this is very dirty. It's not clean, and it would cause a lot of noise. That's why we use extremely clean front surface stuff. So what we're going to do now is we're going to shine the laser light on this piezo element. And my laser, did it die? There it is. You can see the farther away that I go. Oh my god, it's a fucking alien light. I got an alien eye on there. Oh, that's pretty cool. So you put it up against the wall, it shows that image. Ow, damn it, fucker. Alright, it shows, it shows an image there. If you look at it really close, you can see that shape that it's putting out. Now, what I'm concerned with is the dot in the middle. Okay, so the fact that you can see that reflection is proof that it's reflecting off of that. So when it bounces back off with the mirror, it's going to bounce, it's going to bounce back off and then go through the mirror and shit. I just said that twice. Now another thing, if you notice around the eye there, you really can't see it that well, but yeah, you can right there. All that other stuff, that's noise. That is light noise. And that's all filtered out and stuff. But that is reflecting. So we could modulate the second mirror that's going through. Oh my god, I just fucking designed this right in my fucking head just now. That's what he was trying to do. That's what Erland was working on. He was working on something like this, but he didn't have it right. Or did he? He had speakers. Actually, he was using a speaker. But the problem with what he was doing is that he was bouncing the light off of the speaker, but that light was not being reflected back into the center of the circuit like you see over here. So we take this micrometer adjustment and use this as a means of nullifying the noise. So now we're going to have so the question is, so that's a piezo element then. There's no reflection. We don't have to have this. So let's go ahead and take, let's go back to select. Let's go to paste. So we do not need to combine the light source. let's write down, let's see, let's do here. Is it piezo element for signal. And then we'll do purple. Now on that piezo element, we could attach a piece of aluminum to make it more reflective. This is using light waves. So once this is calibrated with a certain frequency of the light wave, we would have to use a harmonic of the, well, the black light is only going to be at a certain frequency, isn't it? How do we select the frequency above ultraviolet? So those mirrors and that piezo thing don't have to be very far apart. Huh. So for that, we're going to have to have a board set up for this. And then the other part is you've got to transduce the light back to energy that we can hear. So that would be you couldn't use a piezo element. You'd have to use a detector, a photo detector, a photo detector. You could even use, remember we talked about that other thing. If this is going to be information over time, we have to be able to collect those time particles. One photo detector, you could use okay, so let me put in another thing here. So this would be like this. Gradually, wait, this needs to be like fucking small. Gradually move to get rid of noise. And we use a line. Jesus, I don't even know if that would be enough. I don't think it would be enough to do it. I think you'd have to. We're talking nanometers. Well, a micrometer is micrometers. So you're converting. All right, so let's go to. We'll just leave that set there. Let's go to. Wait, what the fuck? Nanometer. Micrometer to nanometer. Jesus. 1 micrometer is 1,000 nanometers. Now we need to know ultraviolet frequency. Ultraviolet radiation oscillates at rates between 100 terahertz and 30,000 terahertz. So let's say if we, what is the period? Visible ultraviolet is 10 nanometers. So we've got to have a resolution of 1 nanometer. Resolution of 1 nanometer needed. One micrometer equals 1,000 nanometers. Jesus. So if I move that thing 1 micrometer, I'm going to be moving it 1,000 nanometers. So I'd have to have. What is that? Longitudinal reduction ratio. Oh, Jesus. Architectural gear ratio. Maybe. Oh, Christ, they're talking about fucking people here. Would that be radial? Radial to longitudinal reduction ratio. I don't want to get into health. What the fuck? Realizing high aspect ratio, 10 nanometer feature size in lasers. define the far field by creating a high purity longitudinal light field at focus. Like, I don't know what that distance is, or how I would even measure it. How the hell would I design that? What if I used a friction setup instead of gears? Frictional surface. A frictional surface. How do I know that it even moves, you know? Oh, how the fuck do I, how do I, see, this is a transducer thing. Um, if I used a drill bit, yeah, it's not going to work. If I used spring compression, you know, that would work easier. Wait, so the micrometer thing usually has that other thing on the end of it. Um, if I put a metal plate, if I had a metal plate on there that would attach to the micrometer screw, so let me see here. Let's use purple. Here. So wait, actually, let's use a blue color. We draw a line. And then we'll use a green color. And we'll draw another line. And then freehand a larger size. It's going to be around this, isn't it? Where's red? Let's cross this out. Okay, so this is a metal plate, and then what's going to happen is we're going to have a spring. And then we'll put another straight line here. So if this tension is going forward, no, this is not quite the way I envisioned this, because now there's no gear reduction. Whereas there's gear reduction on the bottom. That's not going to work. I've got to have gear reduction. That's not gear reduction. Oh, shit. Where's A? And this is going to be brown. Yes. Yes. Need gear reduction. And then we'll draw a line. So I have to have a setup of springs, maybe. And there has to be gear reduction. I don't know how I would connect. I got some gears, actually, but what about a belt? I could use a belt. Actually, no, I can't, because the micrometer, unless if I take the micrometer. Actually, does that micrometer turn? I think it does. That's something I'm gonna have to come up with a design on my own without. I mean, I don't know. I could stream it. I'd have to think about this shit, you know? I don't like thinking. That's that story. That's that story. And then there's sources of light could be polarized. You know, there's all kinds of stuff. That's a separate. This is like a separate section that I'm not even supposed to be dealing with in my stream. Yeah, we would have an advertisement there. Um, Jesus. I don't know how long that BS was sitting there. Well, it couldn't have been that long because I had my other thing up. Wait, is this even the right one? I don't even know. I don't have it up anyway. Where am I back to? I'm back to web page, website. Um, so I went over that anyway. What else is here? There's an appendix here. This is all the Spiritcom stuff. All the stuff there. Mickelson Morley. And we did that. And you can hear some of these are the sounds. This is all the supposed time stream stuff where they were trying to talk to the technician. Let's just hear what this sounds like. See that? That's the voice from the other. Where the hell did it go to? I didn't even get into. Oh my god, did I fucking lose it? Where did it go? The fuck? Oh, it switched the page. So now on that feedback here, may I suggest that you change that, the resistor I mentioned? Oh, I found the schematic for that, sir. You did. One of these persons is deceased. We have stated in my the fact all administrators, one of which was a value managing point, was clearly showed in the tone of his voice when requesting that the camera be turned off so that he could make some kind of person on stage to William. Yeah, I don't know who's who in that.
The schematic for that, sir.
Oh yeah, you hear the differences in the voice? These are using those tones. That's why the guy sounds like the amplitude's not changing, but he sounds robotic because he's using the energy from the tones.
Yes, sir. I don't have the schematic for the one the cheapie I bought at Radio Shack, but that's the one I've been using. You're joking? No, I'm not joking, sir. That cheapie? Yeah, that cheapie. That's the one I was using when you showed up on television last night. And I guess you noticed how, well, I'll have to admit I was somewhat frightened when Mom, showed up. And earlier in this tape, I had promised George that show him somewhat of what we had accomplished with Vidicom. We don't have any facial features or anything like that yet, but both you and Mom, and I don't know who the other person is, I said just anybody else who comes with the love of God and is friendly, but I don't know who it was, but I just invited anybody, and did you notice the interruptions? Oh, yes, you did. Good. So, I don't know. There's just not enough hours in the day anymore, Doctor. Well, you've got to get your rest. I know I have to get my rest, but there's just not enough hours in the day anymore.
Pretty cool, huh? Cannot be here forever. He's talking. This guy is theoretically talking to someone that has passed away.
Yes, sir.
Did you make that telephone call yet?
No, sir. Yes, sir. You're not be here forever. I cannot guarantee how long I can be visiting here. However, I will do my best. You understand what it is? Yes, sir. There's a time and a place for everything. So, as I have mentioned before, there's some things I think you should be aware of.
Some things that you need to be aware of. There's a time and a place for everything. So as I mentioned before, this is something I think you should be aware of. It's freaky. There's a long William Crookes, woman sitter. Well, I think William Crookes. Let's listen to this one. This is 5 minutes long. This is a different spirit.
And I must admit, it's a great pleasure to me and others here to sometimes have the opportunity of endeavoring to break the bonds and the barriers and get through on some sort of level which is nearer our own condition of life and way of thought. And I'm very glad that you particularly are endeavoring to assist us in this.
Well, I think you're perfectly right in all that you say. I wonder if you were a spiritualist yourself when you were on the earth.
I most definitely was a spiritualist, and like a good many more spiritualists.
Well, that was rather clear. That didn't sound... Yeah, there's a lot of stuff there that's on that website. I mean, you know, it's just a matter of checking it out. George W. Meeks, we did that, and Mark Macy's got stuff for you now. I want to get going. This person here has a website. I believe she's still alive. This is the fellow that I met personally, and he talked about his laser setup, which is what we just went over, but he wasn't able to do it. And there's a whole thing about his stuff here. His experiments, his meetings, his laser setup, you know, it looks like that's a laser board. Like, I wanted this stuff. I wanted to take this stuff home. I was down there with the truck. But it's okay. This is a perfectly machined board with perfectly aligned holes. It's very heavy and whatever, you know. I don't know how they get that picture of the laser. Okay, so there's his, why don't we just grab this web page really quick here. What is all of this? ITC bridge. I'll just put it up here. Maybe we can go over that because in light of what we just did. So he's got a microscope objective, he's got a mirror, he's got a tape recorder, a micro generator, he's bouncing that off the speaker. See where he's got a speaker? He's got his tone generators going through the speaker and a micro generator here. I don't know what 60 times he's using micro objectives, a beam splitter, and a laser. So the problem with this, okay, is that he puts the sound on, I don't know what he's doing, but he's not putting the sound on the non-reference beam. Or is he? Actually, he is. Wait. Where's? So the reference beam is the first. The reference beam is the first beam goes to the right. It goes to the microscope objective onto the micro generator plate. Then he's got the second laser beam going to the speaker, which is vibrating the sounds of the laser onto the micro generator. The problem with how are we adding the tones to the light? Oh shit, I didn't discuss that, did I? Where's my picture? Is my picture up? I took it down. I'm using the piezo element. I'm using a piezo element instead of the speaker, which is far more sensitive. He can't, how can you reflect a thin reflective cover? So he's got a cover over the speaker, and what I'm doing is I'm using a, okay, and so here the speaker is coming off the secondary mirror, whereas in my setup I'm using this mirror section is actually going to be the piezo element. But then you can see that they're both going, so there has to be, if that's the piezo element and that's reflected, there's got to be another mirror to send that back to the dual mirror setup. Actually, you know what? We could actually save this and put this in documents. And this is going to be laser 2. So I was using, yeah, the laser setup is different. It's got the sound portion on the outside of the laser setup, whereas my sound portion is going to the inside of the setup. It's another way to do it. But my setup uses that dual reflected, it uses the beam splitter. And then it does this here. It's reflecting. In other words, this mirror is not reflecting back into the beam splitter. It's reflecting back out, which is sort of interesting, I guess. Maybe this is a better idea because it keeps the sound, it keeps things different, I guess. I don't know. This is a different setup. I don't know exactly what that's all about. This is where he went to go on, he met this fellow. He was making a dish, winding a dish or something. A roll of Met glass that Hans Heckman used to wind into the large parabolic dish. Part of a large laser system used to modulate another laser. The disc is being wound in Met glass formed one heck of an inductor. The whole works is supposed to create a resonant vortex at the place where you put the paper. We had run the system up to 400 watts, but there was one insurmountable problem. The dish was facing my gas meter for the house, and my wife was against an explosion happening in our basement. So there's some stuff happening there. I don't know exactly what it all is, but hey, there's a Tesla coil built by. That's another thing. You can take static electricity and do the same thing as what we're doing here, but how would you, that's another project. It's static versus magnetic. We haven't looked at the magnetic waves are going to be a much higher wavelength than these laser waves, than these ultrasonic waves. Higher wavelength meaning much lower frequency. But I contend that magnetism is involved. Here in this other circuit, maybe we could concentrate on that. Now, here's the laser voice from Mr. Babcock here. I mean, you can't distinguish anything from it, I give him a lot of credit. He tried to do something. Let's see. Attended to photograph be visible, etc. Showing a bright line source the size of a dot. So from this point, static green is thunder going towards the screen accompanied by 2 weaker collateral rays. Front of the screen, the spinal rays disappears, but then becomes visible on the right side, and it's most periodically sequenced and longitudinal by lighter and darker crystal. Taking the photo, Babcock neither perceived the light source nor the green ray. Oh, after he took the picture shows the rays, but just looking at it doesn't. Well, that's his stuff there. And there's the other researchers, ITC, World ITC, yep, that's the site. And anyway, getting back to what I was supposed to do, which I haven't even done yet. Hello, is this to do with optics? I just got done going over the section regarding setting up a laser, which for some reason I'm not seeing. Wait, what is this here? It must be this picture. Let me just back up here. Open with paint. Okay, yeah, this is the picture I was working on. Let's see here. So there's this here where you get a light source, one light source that has no information, and the other light source, which has information on it, is vibrated through a piezo element, which is probably frequency modulated or pulse width modulated, and that all gets collected into a receiver. And the other picture, the other one, let's see here, is this one. So Mr. Babcock used this setup where he put the sound source on the outside of the laser rather than using the mirror itself to vibrate to add the noise to the reflected source from the laser. I believe in both cases you can eliminate the noise from the laser and come up with a signal. Not 100% sure about that. But it's interesting. It's just a basic hologram type laser setup. And it could be, you could set up a picture from it. However, I believe the information is going to come up looking like a Fourier transform, which is basically a collection of dots looking like waves, and those waveforms need to be collected over time. So exactly, I'm probably going to use a photo detector to detect the final output. Don't exactly know, it's just that's working with light waves. But I wanted to set up my discrete circuit to amplify some stuff. But I gotta take a break, and maybe I will go over my circuitry. I got a picture here. Where is my video capture? This is my electronics lab here, and I was working on an amplifier setup, which is down there, using an op amp. But I'm not going to do that. I'm going to work on the secondary stage, which is using transistors instead of an op amp. So that's for trying to do some phase reversal stuff. I'm going to do that later, but I got to call it quits and take a break, get something to eat. Thanks for hopping in there. Hopefully you'll be back again sometime.